Good morning, students. In my last video, we discussed dispersion of white light through a glass prism. After dispersion, it gives a 7-color band that is called spectrum. In this video, now we have to discuss recombination of the spectrum of white light that is produced with a white light. When a beam of light is passed through a glass prism, as we know that it is split up into its 7 component colors, that is VIBG, YOR, and these 7 colors are allowed to fall on an inverted glass prism. Then it recombines all the 7 colors and again produces the white light. That is, in this diagram, first we are seeing the white light is passed through the first prism, that is P1. Then it gives 7 colors. Again, these 7 colors, when passed through the inverted prism, that is P2, then the emergent light will come as a white light on the screen. It is the recombination of the spectrum of white light that again produces the white light. Then the next one is rainbow formation. As we all know that the rainbow is a natural spectrum appearing in the sky after the rain shower. Why this rainbow is caused? It is caused by the dispersion of sunlight by the water droplets. They are present in the atmosphere. The water droplets here act like a small prisms. First, they refract and again disperse the sunlight, and lastly reflect it internally and again finally refract it, and again when it comes out of the raindrop. And due to this dispersion of sunlight and internal reflection by the water droplets, we see the rainbow colors. If you see here, the first here, the sunlight that enters the raindrop. While entering, the light passes from one medium to another medium. Then it is the refraction, and dispersion also takes place. And in the second step, this point is called A. Here is the refraction and dispersion takes place. And in the water droplets, the same medium, it is called reflection. Internally, in the water droplets only, the reflection takes place. That's why it is called internal reflection. This is taken as point B. And finally, it refracts and gives the band of color that is taken as a spectrum, or you can take it as a rainbow. And they can ask the question like you draw the diagram, and they point A, point B, and they give point C, and in point A and point B and point C, which phenomena takes place, whether the refraction where takes place, the internal reflection where it takes place, again the refraction is where it takes place. They can ask the question like you. That way you can remember this one. And next is atmospheric refraction. Then if you completely know this atmospheric refraction, then we can know the remaining all concept of this chapter. Then, as you already studied, the refraction is the bending of light when passes from one medium to another medium, it bends towards the normal. It is taken as a refraction. But here we are going to study is atmospheric refraction. Then what is meant by atmospheric refraction? It is due to the gradual change in the refractive index of the atmosphere. In the atmosphere, the refractive index is gradually changes. That's why this atmospheric refraction is takes place. And the refractive index of the atmosphere, it gradually increases towards the surface of the earth. While from atmosphere, when you are coming nearer to the earth, then the Ri value, refractive index, gradually increases. And why this is because the hot air above is less dense than the cool air below. Whatever the towards the earth, the cool air is there. Compared to that one, the above air, hot air is there, that is less dense. Less dense means rarer medium. And the earth surface, towards the earth surface, whatever the air is there, that is cool air, that is taken as a denser. Then the hot air above is less dense than the cool air below. It means whatever in the atmosphere, that is rarer medium, and whatever the atmosphere is there towards the earth, that is called a denser medium. When a ray of light coming from rarer to denser medium, then it bends towards the normal. That's why the light gradually bends towards the normal. And so the real position of the star is different from its atmospheric position. Then we can take here, this is the observer eye. Then from atmospheric to earth level, the Ri value gradually increases. Actually, the star position is here. That is the real position of the star. Then while coming towards the earth, the ray of light bends. Then whatever the bending you can extend it, then the star appears here. That is called as a apparent position. And if you see this diagram, then whatever the atmosphere has a different level. It is first level, then it is second level, and it is the third level. Then when it is actually the star position and observer is here. When from atmosphere coming from the earth towards the earth, then the ray of light bends towards the normal. That is why the refraction, when normal, then it bends towards the normal. Again it normal and bends towards the normal. That is why if you see directly here, then the actual star position appears this side. This is called as a atmospheric refraction. Then with the help of this atmospheric refraction, we can further discuss some later 2 to 3 concept of this chapter. Dear students, please kindly like, subscribe this channel and share to your maximum friends to get maximum marks in your 10th science subject. I request once again all of you, please kindly like, subscribe and share this video for your further updation. Thank you.